Okay guys, here we are on part 2 of going through the fall semester exam review, and we'll flip over to our work. We're looking at number 27 here. The instructions say write the standard form ax plus by equals c of the equation of the line through the given points. All right, and here are the given points for number 27, 1 comma negative 2 and 0 comma 3, or 0 comma negative 3. Okay, so let's flip back to our work surface. All right, and so I've written this out kind of condensed form. Here are the 2 points we want to find the equation of a line for, and we need to find that equation in standard form. So the process for finding an equation in standard form given 2 points is actually twofold. Our attack strategy here is first, we're going to find the equation in slope-intercept form, and then we'll convert it to standard form. All right. So what I'll do first is graph these points, just so you can see the line that we're trying to find the equation of. We can actually probably estimate it visually fairly easily. All right, so first let me draw a little graph. Okay, so this is the y-axis, and here's the x-axis. Okay, and this is going to be 0 right here. 1, 2, 3. -1, -2, -3. And 1, 2, 3 here. All right, so we'll actually plot these 2 points. They give us 1 comma -2. So it's going to be helpful if you get into the habit when you see 2 points, 2 coordinates, label those coordinates x1 and y1, and then x2 and y2. So x1 and y1, let's graph that. That's going to be 1 comma -2. There's that point there, so we'll actually write that coordinate in 1 comma -2. And then 0 comma -3. So we'll go x equals 0 and then -3 right here. So we actually have one on the y-axis. So this is going to be 0 comma -3. So lining up our points, and we can draw a line. Be super careful with this. And it is so easy to be off when you draw, especially with these small squares, so be careful here. All right. There. So there's our line passing through those points. Again, we can actually visually construct this equation, but I'll also show you how to construct it algebraically. So take a look at that visually and tell me what the slope is. Well, if you didn't know where to start, you could start at really either point that you were given. Here we'll start here at the y-intercept. Okay, that's the y-intercept, 0 comma -3. We'll go up 1 and over 1 to get to that other point. So I rise 1 and run 1. So my m, or slope, appears to be, so sometimes I write a little eyeball here to show you that I'm using my sight. M appears to be equal to 1 over 1, or just 1. So that appears to be the slope. And then the y-intercept, again, apparently, is 0 comma negative 3, so b equals negative 3. So if I think, again, apparently, kind of indicated by the eyeball, I think my equation is y equals x, mx, so m is 1, so we just write 1x or 1x just as x, mx plus b, b is negative 3, so x minus 3. So I think my equation is y equals x minus 3, but we're gonna find out for sure. So if you didn't know, or you couldn't graph, or the points were unclear, okay, you could actually find the slope algebraically. So we'll actually find the slope algebraically over here. The way you find the slope algebraically is, I'll show a couple different ways. So the slope is equal to y2 minus y1 over x2 minus x1. All right, so if we plug in those values, y2 is negative 3, y1 is negative 2, so negative 3 minus, be careful here, open parentheses, negative 2. So it's y2 minus y1, so negative 3 minus negative 2. So you're going to have two negative signs there. Over x2, which is 0, minus x1, which is 1. So we just work this out a little bit more. Negative 3 minus negative 2 is really negative 3 plus 2 over 0 minus 1 is just negative 1. Okay, so what is negative 3 plus 2? Well, it's negative 1. We have negative 1 over negative 1. And anything over itself is just 1, so even negative numbers, these negatives cancel out. Negative 1 divided by negative 1 just gives you 1. So that's how we knew that the slope was 1. Again, kind of confirming what we saw visually. Here's another way to do it. Especially if you had a number of points like this, you could see this information as a table. So let me show, here's our XY table that you're familiar with. Okay, this isn't strictly necessary, but depending on how you like to solve these, all right? So we'll just take our points x1 and x2, 1 and 0, and then as long as you're consistent with this, it doesn't matter. Take y1 and y2, negative 2 and negative 3. Okay, we can now do this analysis here where we find the change in x, 1 to 0. What's happening? Well, we're adding 1. And then the change in y, what's happening? Negative 2 to negative 3. What is happening here? All right, I just did it wrong. So 1 to 0 is actually a decrease of 1. So that's wrong. That's negative 1. Sorry about that. And then negative 2 to negative 3, well, again, the same thing is happening. It's getting smaller by 1, so it's going down 1. Little error there, sorry about that. Just to confirm so you don't get confused, the distance between 1 and 0 is 1, and the direction of that distance is negative, so it's minus 1. Same thing over here. The distance between negative 2 and negative 3 is 1, and the direction of that distance is going down, negative, so it's negative 1. And then this version of the slope calculation is m equals the change, indicated by that Greek letter delta for change, the change in y over the change in x. Okay, what's the change in y? Well, it's negative 1 over the change in x, which is also negative 1. So that's another way of saying, well, negative 1 over negative 1 is just 1. Another way of confirming the same thing. Finally, just so you can see it, some people are just more comfortable with the calculator. So if you just want to give you 3 different ways to find the same information. So my calculator here. If I'm going to use this table, I could go to Stat, Edit. I'm going to have to clear some data out of here. And enter in for L1, enter in my X values, 1 and 0. And then for my Y values, I've got -2 and -3. Okay. Now I hit Stat, go over to Calc, and go down to 4, which is len reg ax plus b, and hit enter, 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 and then it actually gives me all the components I need to find the equation of the line. But the key thing here is the a value is 1. So another way of finding 1. Okay, so I think we've established that the slope of this line is 1. We established it visually by drawing it and graphing it using rise over run. We established it algebraically with this measure here, and then we used a table to compute the changes, and we found it that way, and then we used a calculator. I guess we found it 4 different ways. So I think we should feel fairly confident about that. You only need to use one of these ways, preferably this way or this way. Calculator is a backup. Using the graph is always a fool's errand because you could get it wrong visually. So anyway, m is 1. So maybe we'll write that here, m equals 1. Well, what about b? Well, we need y equals mx plus b. And we found m, and now we need b. How do we do that? Well, here's how we do it. We treat this like we have the equation of 1 point. We have an equation, we have 1 point, we have a slope of 1, and we can choose either point here. Okay, now this one's kind of this gives us the y-intercept already of -3, so we could just use that point, but let's say it only gave us this point. Okay, so we have a slope, and we have this point. Okay, so let's work it out. We have the point slope formula. Point slope is y minus y1 equals m, open paren, x minus x1, close paren. Okay, so we have y minus y1, which is -2, equals m, which is 1, open paren, x minus x1, which is 1, close paren. Okay, so let's deal with this. Y minus -2 is y plus 2. Okay, y plus 2 equals, now there's nothing to distribute, this is just 1, so we can write x minus 1. Okay, now solve for y. So subtract 2 from both sides, and these cancel, leaving y alone. Y equals x, and now I have -1 minus 2. So on a number line, I have -1, -2, -3, like that. Here's where I am. So I've got -1, and I want to subtract 2. So I'll go down 1, down 2, okay, to -3. All right, so I'm subtracting 2. So -1 minus 2. Again, if you wanted to confirm that another way, you could say, well, -1 minus 2, -3. Okay, it's hard to see. -3. So I'll write y equals x minus 3. So there's my equation in slope-intercept form, y equals x minus 3. So I have to convert y equals x minus 3 to standard form. That's what I'm going to do now. Remember, standard form is ax plus by equals c, where a, b, and c are whole numbers, integers, okay, and that those numbers, that the a is positive. So it's really where a, b, and c are members of the integer set. We could write that as z. I think it's supposed to be like that, like this weird looking z. And then, and where a is positive. Okay, so where a is greater than 0. That's the technical way to write it. All right, so now let's convert. Y equals x minus 3. Remember, so if I want this form, I'm going to move the x value over. So I'll subtract x from both sides. And I have negative x plus y equals negative 3. Am I done? No. I have whole numbers right now. I have negative 1, 1, and negative 3, but I can't have a negative right there. So I need to multiply the entire equation by some number that will cancel out that negative. And when you just have a negative in front of a variable, the thing that will cancel out the negative is just negative 1. Okay, so we're going to multiply negative 1 through the entire equation. So by every term, we're essentially changing all the signs. So negative 1 times negative x just gives x. Negative 1 times y gives minus y, or negative y, equals, and negative 1 times negative 3 gives positive 3. So my standard form equation of the line is x minus y equals 3. Okay, so what we'll do is go back to our homework and see if that's one of our answer choices. X minus y equals 3. Okay, so it's B. See, that's the one that's got all of the things that we wrote. We'll go back to our work. The answer to number 27 is B. All right. Now again, if you were wanting to roll through this problem quickly on the calculator, you enter your data under Stat Edit. You enter your data, L1. You put in, I can somehow show this better. Put in your L1 and L2 data. So for L1 it was 1 and 0, 1 and 0, and then for L2 it was negative 2 and negative 3, negative 2 and negative 3. All right, so now go back to Stat, Calc, linreg AX plus B, enter, 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 and then you're given A equals 1, B equals negative 3. So that means the slope is 1, the y-intercept is negative 3. So again, y equals x minus 3. Again, from there you would still have to perform this conversion to standard form, but at least it would have eased your burden a bit in getting slope-intercept form. So however you want to solve it, that's fine. But please show your work. So that's number 7, shown a couple different ways. Or number 27 rather, shown a couple different ways. And we will move on to the next section. Let's go to our work and see what the next section asks of us. All right, scrolling down, some more standard form work. Write the standard form equation of each line. Standard form is ax plus by equals c, where all coefficients are whole numbers. It should also say, and a is positive. Okay, so let's look at number 31. At this point, we should be getting pretty good at this. Number 31, we are given the slope-intercept equation of a line, y equals negative 1 over 4x plus 2. Okay, and we're going to convert that to standard form. So I'll show my work surface again. And here's the equation we need to convert to standard form. The first thing we're going to do is remember that standard form is ax plus by equals c, where a, b, and c are positive, and where where a, b, and c are whole numbers, and where a is positive. So again, we're focused here. I want to move this x term over to the left. So I will add 1/4 x, 1 over 4x to both sides. 1 over 4x to both sides like that. On the right side, that cancels out, and I've got 1 over 4x plus y equals positive 2, or just 2. Is this standard form? No, because we have a fractional coefficient in the a position. So I need to multiply the entire equation by some number that will get rid of that fraction. Now remember what we talked about in the previous problem. If you have a fraction like that, you can just multiply the entire equation by the reciprocal of that fraction. So the reciprocal of 1/4 is 4 over 1. And what that will do, at least for this term, 4 times 1 is 4, 1 times 4 is 4, you have 4 over 4, and that whole thing reduces down to 1. So when we do this distribution, okay, when we do this distribution, you'll see this whole thing disappear for the x term, and we just have x, because 4 times 1 is 4, and 1 times 4 is 4. 4 over 4 cancels down to 1x. We don't write the 1, so we just write x. Now, 4 over 1 times y gives plus 4y equals 4 over 1 times 2 gives 8. So x plus 4y equals 8, and that is the standard form equation of that line. All right? Let's go back to our answer choices and see if that appears as an answer choice. For number 31, x plus 4y equals 8. All right? And there, B was the answer to that one. So that was a quick one. B for number 31. Okay. Look at number 32 real quick. Just want to talk about this for a minute. Y equals 0. Okay, so what does that look like graphed? Well, that just means that you have a horizontal line where y equals 0. Okay, y equals 0 is literally the x-axis. So what is the standard form equation? In other words, there is no slope. The slope is 0. So you have y equals 0x plus 0. So y equals 0. If you want to find the standard form of that, you're actually currently looking at it. It's a weird question. 32 is B. We don't have an x factor, so it's just y equals 0. 32 is B. That's a weird one. All right, let's move on to the next section. Write the standard form equation of the line through the given point with the given slope. Okay, no problem. Number 35 is what we'll work on here. Number 35, passing through -4, comma 4, -4, so -4, comma -4, with a slope m equal to 9 over 5. Okay, so what I'll do is flash back to my work surface here, and we'll focus in on number 35, and here I'll draw a graph just so you can see what we're trying to do. So I have to be a pretty big graph because of the slope being 9. So I have to do see how I'm going to show this. I'll put the x-axis here. This should work. Okay. Here's my y-axis and my x-axis. And first I want to kind of draw this in 0, 1, 2, 3, 4, 5, 6. On the y-axis going down, -1, -2, -3, -4, -5, -6, -7, -8. Okay, that's enough. Okay. And then here I'll go over 1, 2, 3, 4, 5, 6, 7. Okay, so our first task is to plot the point that we're given. So that's -4, -4. So what we do, I guess I need to extend the x-axis into the negative side a little bit. Okay, so I'm going to have to write -1, -2, -3, -4, -5. What we'll do first is find -4 on the x-axis, right here, -4, and then go down 4 from there. So down 4. Okay, so I should be at -4, -4, -1, -2, -3, -4. Yep, right there. So that right there is -4, -4. And then I have a slope of 9 over 5. Okay, so down here, if m equals 9 over 5, this is equal to the rise over the run. In other words, I'm going to start here at this point that I was given and go up 9 spaces and then over to the right 5 spaces. Right? So starting at -4, 4, go up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then go over to the right 5. 1, 2, 3, 4, 5. Right there. Okay. So I'm going to draw a line passing through those 2 points right there. Be real careful with this. Okay. And just looking at it visually, it kind of looks like this line might not pass through the y-axis at a whole number value. It looks like it's between 3 and 4. I could have drawn it wrong, so we'll check that one time. Go up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Over 5. 1, 2, 3, 4, 5. Nope, I drew it correctly, so we'll see. So that's visually what we're trying to find. Now I'll show you a couple different ways to solve this. So we're given a we're given a coordinate pair, and we're given a slope. So when we see stuff like this, we want to use the point slope formula. Point slope again is y minus y1 equals m open parentheses x minus x1 close parentheses. Okay, so now I'm going to plug in my values. This is x1 and this is y1. Be super careful with these plugins because you're going to have 2 minus signs next to one another. So y minus open parentheses -4 close parentheses equals, now what's m? M is 9/5 equals 9 over 5 open parentheses x minus another open parentheses -4 close parentheses like that. Now we're going to get rid of these parentheses and fix the signs. So I have y minus -4, y minus -4 equals y plus 4, okay, equals 9/5 times x. I can just write 9/5, and then we'll do that in a second. X minus -4 plus 4. Change that there. Okay, and now we're ready to solve this out. Y plus 4 equals 9 over 5 x, and now distribute that 9/5 to both terms. Okay, so here we need to do a little bit of math. 9 over 5 times 4 over 1. Because I'm multiplying 9/5 times 4. Multiply the top, multiply the bottom. 9 times 4 is 36. 5 times 1 is 5. So I have 36 over 5. Okay, so 9/5 x plus 36 over 5. They have no common factors, so we just write 36 over 5 like that. Now, what I want to do is subtract. I want to get y by itself, so subtract 4 from both sides. Now I have that canceling out, and y equals 9/5 x, and then I have plus 36/5 minus 4 over 1. Well, we have a problem. I cannot subtract 4 over 1 from 36 over 5 without having a common denominator. So I need to multiply 4 over 1 times 5 over 5, and that will give me a common denominator. So I'll write this again. Y equals 9 over 5x, okay, plus 36 over 5. Now we got to do this. 4 times 5 is 20. 1 times 5 is 5. So minus 20 over 5. See, I found a common denominator there like that. Okay, so now we'll just keep solving. Y equals 9 over 5x. Now I have 36 minus 20, which is 16. So y equals 9 over 5x plus 16 over 5. Okay. Now let's just check to make sure we're right. What is 16 divided by 5? 16 divided by 5 equals 3.2. Now go back to our graph. Sure enough, that y-intercept, okay, is between 3 and 4, and it's even drawn right. It's about 3.2. Okay, so this y-intercept is now known to be 0, 3.2. And 3.2 as a fraction is written as 0, 16 over 5. So actually the fractional form will be the most useful because we still have to convert this to standard form. Okay, so we're going to convert y equals 9 over 5x plus 16 over 5 to standard form. Standard form is ax plus by equals c, where a, b, and c are whole numbers and where a is positive. So we'll just start converting. Remember, my first task is to get the x value over here, so I'll subtract 9/5 x from both sides. And on the right, it cancels out, and now I have negative 9 over 5 x plus y equals 16 over 5. Okay, so now we have a problem because we actually have two fractional components of our standard form. So put the whole thing in parentheses and take a look at it. This time, if I were to multiply the entire expression by the reciprocal of this term right here, I'd be multiplying by negative 5/9. And that would certainly get rid of this term, but it would screw up this term. Okay, we'd still come out with a fraction over here. So I have to think, what can I multiply the whole equation by in order to make this a positive whole number and make this a whole number, not necessarily positive? If you think about it for a minute, if I multiply by negative 5 over 1, when I multiply that negative 5 over 1 times negative 9 over 5, I'll end up with positive 45. Well, let me put it this way. If I multiply negative 5 over 1 times negative 9 over 5, these 5's will cancel, and negative times a negative is positive, so I'll have 9x. Maybe I should show that, the whole thing. So I'm going to show each distribution so you can see it happen. We're going to multiply negative 5 over 1 times negative 9 over 5x plus negative 5 over 1 times 1 over 1 y equals negative, so again, negative 5 over 1 times 16 over 5. All right, this looks really frightening, but we're going to be able to cancel a lot of this stuff out. So here, I'll use red to cancel. Here, the 5's cancel. Okay, so we're really multiplying negative 1 times negative 9, and that just gives 9. So I have 9x here plus, or well, maybe not plus. Let's just do it. I have negative 5. These 1's are canceling out, so I just have negative 5 over 1, or negative 5y. Okay, equals, now this is where we're going to have to do a little bit of thinking. Do you see that these 5's cancel? Okay, the 5's cancel, and I'm left with a negative times 16 over 1. In other words, minus 16. You might need to pause the video and go back and look at that again. This process here takes a little bit of getting used to, but this looks like the simplified standard form of the equation. That one was kind of fun because we actually had to think about it. Let's see if we have that as our one of our answer choices for number 35. Okay, so transition out of this, go back to number 35, and we found 9x minus 5y equals negative 16. 9x minus 5y equals negative 16. So for number 35, we found that B was the correct answer choice. That was a good one. So B is the correct answer choice for number 35. Okay. So now we will go back to our work set and scroll down, see what's next. Okay. More standard form. Write the standard form equation of the line described. Okay. Now it's asking us to do it with parallel lines. Okay. So here's what we're given. Remember, parallel means same slope. And let's do number 39. Number 39, we are given points 4, comma, negative 3, and then told to find a line parallel to y equals negative 1/2 x plus 4. Okay, so let me flash back to our work surface here. All right, so I could graph this, and if you know me at all, you know I will graph it. Okay, so here is a graph. So this is going to be y and x, 0, 1, 2, 3, 4, 5, negative 1, negative 2, negative 3, negative 4, negative 5, 1, 2, 3, 4, 5. Should be enough. Okay, so let's plot the point that we're given, 4, comma, negative 3. So we'll go over 4 and down 3 to this point right here. Okay, that is going to be 0.4, comma, -3. All right, and now, so that's the point we're going to have the line pass through. But so forget about that point for just a second. Now we're going to plot this line right here. So y equals mx plus b. Remember, y equals mx plus b. So b is the y-intercept. Therefore, b is 4. So we go to the y-axis and find 4. Put a little dot there. This is 0, 4. All right. And now we are given a slope of -1/2. And what that means is go down 1 to the right 2. Conversely, you could go up 1 and to the left 2. But we'll do it down 1 to the right 2. Rise over run. Down 1, right 2. Okay, so down 1, right 2. Down 1, right 2. Down 1, right 2. Down 1, right 2. Okay, so now we can draw our line. So we know that we're going to, that's the equation of our line, y equals -1/2 x plus 4. That's the equation of the line graphed. Now we have to remember that the line that passes through this point is going to have identical slope to this line here. So we can actually build our line using the slope. Okay, so the slope m equals -1, -1/2. Okay, -1/2. So remember, I can actually build my line from this point. I know the slope, so I can go down 1/2, down 1/2, down 1/2, just like that. I can also go up 1/2, up 1/2. And I just found my y-intercept at 0, -1. All right, so now I'm going to draw my line passing through all those points that I just graphed. And it should be exactly parallel to the line I just drew. Okay, so that's the equation of the parallel line. And we know the slope is -1/2. And we found the y-intercept by graphing. Just so happened to be on a whole number there, 0, -1. So right there, that's what my eyeball tells me b equals -1. So if the slope is -1/2 and the y-intercept is -1, it apparently is the case that my equation of my parallel line is y equals -1/2 x minus 1. That's apparently what I've found. Okay, now I need to write that in standard form, but first I need to make sure that I did this correctly because I just did all this visually. So let's go back to our equation and we will actually use point slope. Use point slope. Okay, remember point slope is y minus y1 equals m, open parentheses, x minus x1, close parentheses. Okay, so we actually know y1 and x1. Here they are. This is x1 and y1, 4 and -3. So we'll plug those in to our point slope. We got y minus y1 of -3, so little open paren -3, don't mess that up, equals m, which we know is -1/2, open paren, x minus x1 of 4, close parentheses. Okay, so let's take care of this little mess here. Y minus -3 is y plus 3 equals -1/2 x. Okay, and now multiply -1/2 times -4/1, and you get +4/2, or 2. Okay, so -1/2 x plus 2. I'll subtract 3 from both sides. Cancels out, leaving y alone. Y equals -1/2 x. Okay, 2 minus 3 gives me -1. So does this match what we found visually? Y equals -1/2 x minus 1, y equals -1/2 x minus 1. They match. So again, I'm pretty confident that we're right. Okay. So now we need to convert this to standard form. So now convert y equals -1/2 x minus 1, which is in slope-intercept form, to standard form, ax plus by equals c, where a, b, and c are whole numbers and a is positive. All right, so just like in all of these, I have to move the x term to the left side of the equal sign, so I'll add 1/2 x to both sides. And I have 1/2 x plus y equals -1. Okay? Is this in standard form? No. I need to multiply the entire expression by the reciprocal of the a term, which a is 1/2 right now. I need to multiply by 2/1 to get rid of the fraction. So I'm going to distribute, multiply 2/1 through each term. So now that goes away. That just becomes x plus 2y equals 2 times -1 is -2. So x plus 2y equals -2 is the standard form equation of a line parallel to this equation passing through that point. Okay, so let's go to our answer document and see if we come up with that as an answer. We're looking for x plus 2y equals -2 for number 39. X plus 2y equals -2 is answer choice C. Okay, so answer choice C. There we go, answer choice C for number 39. All right, I highly recommend graphing. It'll give you a more intuitive feel for what you're doing algebraically over here, because this is meaningless to me in a visual sense. This makes more sense to me, but I confirm it both ways. All right, so we did that section. We'll move on. New section. Okay, let me share my display with you. All right, so now I'm going down to number 43. Write the slope-intercept form equation of the line. Hint, just solve for y. Okay, so this time we're gonna work backwards. We're given a standard form equation and we're gonna turn it into a slope-intercept form equation. So number 43, we are given x plus 8y equals -48. All right, and we're going to convert that to slope-intercept form. Transition back. Here's the problem. We want to convert this to slope-intercept form. So this is currently in standard form. ax plus by equals c. Okay, what we want is slope-intercept form. We want to convert this to y equals mx plus b. What that really means is solve this standard form equation for y. So we're getting pretty comfortable with this. We're actually just going to do in reverse what we've been doing over and over and over again. So in this case, I want to get y by itself. My first step is to subtract x from both sides. Okay. Trying to isolate y, so I just have 8y now. Remember, these are unlike terms. Okay, here's an unlike terms. So they can't be, you can't do anything with them except set them, next to one another. So just put negative x minus 48. Don't try to combine those in any way yet. All right, so now we have 8y equals negative x minus 48. So we're one step away from our goal. Divide every term in the equation by 8. Just like that. The 8's cancel on the left, leaving y alone. And then we have negative x over 8. We'll have to work with that a little bit. Minus, now what's 48 divided by 8? Okay, if you don't know, it is 6. So minus 6. That's just 48 divided by 8. Now what about this? This doesn't look, it looks kind of like slope-intercept form, but I don't see the slope. Where is that? Well, this is very common in algebra. You have something like negative x over 8, and you need to factor out the numerical part of this and leave the variable all by itself. So I just want to show you that negative x over 8 can be written as negative 1 over 8 times x. Okay, so this is something you might need to pause and do again and again until it becomes hardwired into your brain, because this is important. If it had been negative 3x over 8, okay, then I would have written negative 3/8 times x. In this case, there's just the variable in the numerator, so that's like a negative 1x. So I factor out a 1 and in the numerator, a negative 1 in the numerator, and an 8 in the denominator, leaving negative 1/8 times x. So I can rewrite this y equals negative 1 over 8 x minus 6. And that is the slope-intercept form equation of the line. Okay, y equals mx plus b. Okay, in this case, m equals negative 1 over 8, and b equals negative 6. All right, so can I find this in my answer choices? Negative 1/8 x minus 6. This is number 43. Y equals negative 1/8 x minus 6. Okay, there's your answer. It's A. So number 43 is A. Okay, those are all solved in a similar way. Okay, I'm having you do a few of these because it is a super important skill to convert from standard to slope-intercept and slope-intercept to standard. Okay, now on this new section, we're going to have to pull from the graph the information. Okay, so the very first thing to look at is we're going to find the y-intercept and the slope and kind of build our equation from the visual data. So I'll let you look at number 52 for a minute and try to identify the slope and the y-intercept visually while I draw it out. Number 52. I want to make this look kind of like the way it looks on your screen. Number 52. 0, 1, 2. I'm changing the scale on this graph, so I gotta be careful here. -1, -2, 1, 2, 3. This is 1, 2, 3, and then -1, -2. Okay, so I'm still working on getting this thing graphed. So it looks to me that the y-intercept is 0, 1. Okay, it looks like that. So here's 0, 1 is the y-intercept. And then we have this blue line. Now it's time to kind of look at this and think, how do I get to a point where the line actually hits right in the center of all those intersecting grid lines? I've got it happening right here, and I've got it happening over here on the x-axis. So it looks like at 3, 2, I have a cross point, 3, 2, and also at 0, -3, which I don't have space for. This is okay. I think I'm ready to jump back to my work surface to show you what. Okay, so here's the data. I just plotted those points of where they're crossing at the center of grid lines, and I'm going to connect all these dots to try to draw the line that you saw. And there we go. That's the line you saw. We have to write an equation for this line. First, we're going to write it in slope-intercept form, then we'll write it in standard form. Okay. So very first thing, we can see that B is 0, 1. B appears to be, okay, equal to 0, 1. So B appears to be 1. Just trying to be as realistic with my observations as possible. All right, so what does the slope appear to be? Well, we can compute the slope between any two known points. All right, so I'll compute between 0, 1 and 3, 2. Let's see, we go up 1, up 2, over 1, 2. Whoop, I'm just doing this wrong. All right, so my my scale is different. So that's this big jump here is from 1 to 2. So that's whoop, up 1, over 2, over 3. Okay, I just want to make sure that that was clear because I changed the scale. I'm actually jumping from 1 to 2. I'm hopping over 2 of those grid lines. Up 1, and then over 1, over 2, over 3. So it looks like the slope, m, appears to be 1/3, 1 over 3. Okay. So if that's the case, then my equation y equals mx plus b appears to be y equals 1 over 3x plus 1, because m equals 1/3 and b equals 1. Okay, so that's the apparent, from the visual data that we were given, that's the apparent equation of the line in slope-intercept form. Now I've got to convert that to standard form. Okay, so to convert that to standard form, I'm going to make some space over here, convert y equals 1/3 x plus 1 to standard form. Okay, that's what our goal is. So we'll take y equals 1/3 x plus 1, and we want this standard form ax plus by equals c, where a, b, and c are whole numbers and a is positive. So here I'm going to subtract 1/3 x from both sides, leaving -1/3x plus y equals 1. Then I've got to think again, how do I make this thing where there's no fractional component? And the way I do that is by multiplying by the reciprocal of the first coefficient, which is a, which is -1/3, multiply by the reciprocal, -3/1. Then distribute that to each of the terms in your equation, just like that. So -3/1 times -1/3 gives 1, so we can just write x. And then -3/1 times y gives -3y. And -3/1 times 1 equals -3. Okay, so that is the standard form equation of the visual line that we were given visual data for. Let's go back. X minus 3y equals -3 is what we're looking for in our answer choices. X minus 3y equals -3 is answer choice A. Answer choice A. Okay, so that was number 52, answer choice A. Okay, do that. Okay. So there's no instructions for this next section, but we'll work on number 58. It says find the value of two numbers if their sum is 7 and their difference is 1. All right, let me make some space on my page here. Number 58, right? Their sum is 17 and their difference is 1. Let's go back to our work surface. Here's my workspace for number 58. And what it's saying to me is that I've got two numbers. Let's call them A and B. Okay. So we're setting up our system here, a system of equations. Their sum is 17 and their difference is 1. Okay, sum is 17, difference is 1. We can solve this system algebraically using elimination by addition, and that will cancel out the b terms, okay, and we'll have 2a equals 18, and that means a equals 9, and then we can say 9 plus b equals 17, okay, and then subtract 9 from both sides. B equals 17 minus 9, so B equals 8. And that means A equals 9, B equals 8. So you could kind of make this thing look like 9, 8, like that. That's one way to solve it using elimination. The other way to solve it is by using your matrix editor. So we got to put ones in front of these variables here. So in our matrix editor, if that's what you're more comfortable with, I'll show you how to use that. We've got a 2x3 table, and the terms that we put in these boxes are 1, 1, 17, and then 1, -1, and 1. Okay, so now we go to our calculator, turn it on, and we need to go to the matrix editor. So you hit second matrix and then go over to edit. Okay, you have to put in a 2 by 3 table. Then you just fill in the data as it appears here. 1, enter, 1, enter, 17, enter, 1, enter, -1, enter, 1, enter. Okay. Now you hit second quit, then second matrix, go over to math, and go down to RREF, which is letter B, reduced row echelon form. Hit RREF, so there, let it hold there. Now hit second matrix. Now enter on A. Okay, so RREFA, enter again, and you're given this little table. You are given this table 109 and 018. And what that tells you is that the same way these ones are related to one another diagonally, so are A and B related to one another diagonally. So that means that 9 equals A and 8 equals B. Just what we found using elimination by addition. So what we're looking for is 9 and 8 in the first and second positions respectively, back in our answer choices. Okay, well, here they're saying 8 and 9. I think that the thing should have been 9 and 8, but luckily there's no other values like that, so it's got to be B, right? So I'm going to go with answer choice B there for number 58, 8 and 9. Okay. I guess their order isn't so important. Just said two numbers. It didn't have any specific order. So B, 9 and 8 or 8 and 9 for number 58. Okay. I can see the argument for doing another problem in this section because these are kind of complicated. And I'm just going to read this. Joe and Aaliyah this is number 59. Joe and Aaliyah. So what you're going to do here, we're going to have to flash back and forth quite a bit. Just read through this a little bit. Joe and Aaliyah are selling wrapping paper for a school fundraiser. Customers can buy rolls of plain wrapping paper and rolls of holiday wrapping paper. So here we have these two rows. We've got Joe on row 1 and we got Aaliyah on row 2. The two variables are types of wrapping paper. Plain we'll call P and holiday we'll call H. All right, so let's set this up first. This is not ideal situation. But oh, you couldn't even see for heaven's sake. All right. Joe and Aaliyah on number 59. Joe and Aaliyah are selling wrapping paper. Okay, so we're going to create a row with Joe, and we're going to create a row with Aaliyah. All right, and it says customers can buy rolls of plain wrapping paper and rolls of holiday wrapping paper. All right, so what I want to show here is that we have Joe and Aaliyah, plain wrapping paper, and holiday wrapping paper. Plain wrapping paper, holiday wrapping paper. And on all these problems, we're going to be adding these together because we're going to be computing sale totals, and we just need to fill in this information in these little underscores here. Okay, so we're going to go back to our problem and try to fill this information in. Okay, so let me share my screen with you again. Joe sold 5 rolls of plain and 3 rolls of holiday for a total of 105. Aaliyah sold 2 rolls of plain and 3 rolls of holiday for a total of 78. So let's fill in for Joe. 5P, 5 rolls of plain, 3H, 3 rolls of holiday, equals 105. So 5P plus 3H equals 105. Okay, we'll just fill that in. 5P plus 3H equals 105. So here, 5 rolls of plain and 3 rolls of holiday for a total of 105 And then what did Aaliyah sell? Aaliyah sold 2 rolls of plain, so 2p, and 3 rolls of holiday, 3h, for a total of 78. So 2p and 3h equals 78. So 2p plus 3h equals 78. All right, transition back. 2p plus 3h equals 78. Just want to verify that that's correct. Yep. Okay. All right, and basically wants us to solve this system out. We could solve this system, okay, using elimination by subtraction, because you have 3h and 3h, they're both positive. So if you subtract 3h from 3h, you cancel that term out. Okay, so we'll do elimination by subtraction. So 5p minus 2p equals 3p equals 105 minus 78. Okay, so I've got 9 and 15. So that's 9, 29. Okay, is 78 plus 29 equal to 105. You got 15, 1, 9, 10, 105. Okay, good. So 3p equals 29. So p equals 29 divided by 3, because I'm going to divide both sides by 3. So p equals 29 divided by 3, and we should probably do that. 29 divided by 3. Well, 3 goes into 29, 7 or 8, 9 times. 9 times 3 is 27. Okay, leaving 2. Okay, pull down 2 point. 3 goes into 26 times, and then we're just going to be doing 6 forever. Okay, 9.666, repeating 9 2/3. Why does that seem wrong? What did I do? Clearly did something wrong here. Customers can buy rolls of plain, 5 rolls of plain, 3 rolls of holiday, 2 rolls of plain, 3 rolls of holiday. Yeah, for 105 and 78. What did I do wrong? Five rolls of plain and 3 rolls of holiday for 105. 2 rolls of plain and 3 rolls of holiday for 78. Oh, apparently I can't subtract. For heaven's sakes. Okay. So I did this wrong. Clerical error messed up everything. Let me correct that. Many of you probably caught it. I'm sorry. You just get going with these and you find yourself making stupid errors. It's frustrating, especially when you know people are watching. But that is the nature of the game. So let me fix that. Sorry. Okay. Here was the problem. When I subtracted 78 from 105, I subtracted wrong. Okay. So with a little bit of magic, we'll try this again. What is 15 minus 8 is not 9, it's 7. My mistake. And 9 minus 7 is 2. So a little bit of a mistake there, changed everything. 3p equals 27. Okay, so divide by 3, divide 27 by 3, p equals 9. Okay, and that's a better looking number. Now we'll plug that into one of our equations. Okay, so let's go plug this into 2 times 9 plus 3h equals 78. See if I can be a little bit better at arithmetic this time. 2 times 9 is 18 plus 3h equals 78. Subtract 18 from both sides. And we'll try to subtract again. Cancels out on the left. I now have 3h equals 8 minus 8 is officially 0. 7 minus 1 is officially 6. So 3h equals 60. I feel pretty confident about that. Divide both sides by 3. Okay, cancels out on the left. H is now by itself, equals 60 divided by 3. And 60 divided by 3 is 20. Okay, so I'm guessing that this means that the price of plane equals 9, and the price of holiday equals 20. All right, so let's see if that corresponds to our answer choices. Roll of plane is 9, roll of holiday is 20. Looks like B. All right, but just in case that's not the way that you like to solve these, or you just can't seem to get it right. If you can set it up like this, you can use your matrix editor. We'll create a little 2 by 3 matrix here. Use our matrix editor. Most of you are probably doing it this way. We'll certainly avoid embarrassing mistakes like subtracting incorrectly. So here we're just going to fill in 5, 3, and 105, and then 2, 3, and 78. All right. We'll actually use the data that we already entered. The table structure we already entered in our matrix. So we'll go back to second matrix, go over to edit, and hit enter there. We can actually just replace these values. Okay, if you hit down on the cursor, you can just replace the values. 5, enter, 3, enter, 105, enter, 2, enter, 3, enter, 78, enter. Okay. Second mode to quit, then second matrix, go over to math and go down to RREF. Okay, then again, hit enter on that. Then when you're back on the main screen, hit second matrix and enter for A and enter one more time. So you get 109 and 0120. 109, 0120. Again, the same way these ones relate to one another, the same way P and H relate to one another. That's how I know that this is equal to P and this is equal to H. Okay, so the answer choice again, if we compare this to our answer choices, the answer choice is B. Roll of plain wrapping paper, $9. Roll of holiday wrapping paper, $20. So I thought I would do a couple of those systems problems because setting them up is a pain, and as you can see, even math teachers make mistakes. So that is number 59, and we'll stop it there because we're past the second hour mark for this tutorial, and we'll come back and do the third section. Okay, so we have covered a lot of this review. We've covered all the way from this first section, second section, third section, fourth section, fifth, sixth, seventh, eighth, ninth, 10th, 11th, 12th. Now we've covered the 13th section. So now we're going to solve. Next up, we'll solve each system by elimination. Then we'll solve by substitution, sketch the graph of the linear inequality. Okay, that'll be fun. And then we'll solve some distance and speed and work questions. Okay, those are always interesting. And then solve these proportions. And then we will use the distance formula to find the distance between those two points given. And then we'll solve these general equations here with variables, which are kind of weird. Okay, so that's what's coming up in section 3, but we'll stop here for now.